In SPSS, you have many tools you can use to create charts. So here's a whole load of data, and if we go to these ones, these scale pieces, these are all Likert scales. So these are perfect for visualizing in a chart. So I'm going to show you a few things you can do with that. The top here we have graphs, and there's a whole load of options here. I'm going to use legacy dialogues because I find it a little bit clearer, but maybe you'll find the chart builder being an easy option for you. So let's have a look at this. I can just show what is here using a bar chart. So maybe I want to produce a clustered bar chart, and I'm going to do summaries for groups. So let's go here. I'm going to choose, let's have a look. Number of cases, that's good. How many people do various things. I'm going to say gender is going to be the category, and my clusters are going to be, I don't know, let's have a look. Feel acceptable. Does the clothes feel acceptable? So that's our basic start. Go to titles, we can put things in here, or we can go to options, but I'm going to keep this really quite simple. Okay, and out comes my pie chart. So you can see all of the values here are what was given. So 1, 2, 3, 4, 5, 6, and 7. Those are the options we've got in our data. And we can see that males, well, there's less of them, are going to give a lot more of the 6 and 7s. The females are giving a lot more on the 6 and the 4 with a dip around 5. These are basic histograms we're seeing. So that could be the kind of bar chart you're looking for. Let's have a look at some other options. Let's go to, again, graphs, legacy, and go for bar. And this year, I'm going to go times stacked, and I'm going to use summaries for separate variables. So here we are again. Category access is going to be, let's choose gender again. And I'm going to keep going for, doesn't really matter. That's going to go pick up the, let's go for the PVs. They're going into the bars. Now we can look at sort of what value you want to look. Do you want standard deviation? Do you want the median, the mode, how many people? But I'm going to want the mean. That seems pretty good. And let's go to number above. I'll just percentile, that's fine. Mean. Okay, let's go for that. You can see lots of options, depends what you're trying to create. So you've got to know what you're doing. Again, titles you can put in there, and there's different options we can have by that. I'm going to say exclude variable by variable rather than get the out. And let's go. Let's see what this creates. So we see here, this is actually stacking everything up. So we've got the males, females. There's really a big difference around the PV10, the mean on this. So is that the kind of thing you look to? Probably not. The stack bars aren't as popular. So only back onto our bar chart. Again, separate variables for clustered, defining this. Category access again, it's going to be on gender. I'm going to put the PVs in here once again, so we get a really, let's go for those ones. And again, we're on to mean, keep it that way, and let's pop it out. And yeah, it's a very different way of putting it. So we see, rather than having everything stacked up, we see each bar representing how much the mean is on the side, separated by males and females. So males are giving a much higher mean on the social approval than women, which goes against conventional thinking or conventional socio-contextual whatever thinking, which proves gender differences are much less than people really think they are. And then we've got other things about men are generally giving a slightly higher on improved way to perceive, lower on morally good, a little bit higher on reasonably priced, a tad lower, pretty much equal on feel better as a person, and lower of less harm to children. Interpret all this what you will. You can see our syntax at the top there. So yeah, those are bar charts, and we can do some more looking. Go to graphs, legacy dialogues, and what should we look at now? What should we learn? Box plots. Box plots are fantastic. I really love box plots. So I'm going to go into simple box plots. And again, boxes represent, let's just take the same PV5, that's data, and labeling cases by ID number. So in this case, we're just trying to see what the averages of things are. Let's have a look at this. So we can see that we're not breaking everything into male and female or age groups or anything. We're just saying what's the spread of data. So we see that there's a very wide grouping here in PV10, and morally good has quite a tight grouping there, but some outliers around there. Price has got outliers top and bottom. Price feel is quite comparative to social approval. Now you can see here that this PV13 reasonable price has a very similar to identical mean to PV10 social approval, yet the spread is much tighter here. So we can say that people have a more broad sense of social approval than we do here. I would much rather see a box plot than a bar chart. These are much, much, much better, much more interesting to talk about. But we're not seeing any gender differences or any age differences. So I'm going to pop that again. And once again, go to box plot. This time I'm going to go for clustered, define. So I'm going to go label cases once again by ID number. And the category access, I'm going to say gender. And I'm going to keep the same ones of these. Now, of course, if you've got a test where there is a significant difference and the difference is gender, then this is wonderful. If you've got a non-significant test, there's no difference between gender, this is not very good at all. If you've got less than 20 people, so you can't do something like a Fisher's exact, or less than 50, so you can't do something like chi-square, then box plots are a really good way to qualitatively look at could there be a gender difference, but you can't say there is, you just say it looks a bit like that. So anyway, that's me yapping along, click OK, and here we are. Now see differences at the top here with this nice big box plots with lots of people all together, and then here we've split them out into groups. So we could have run a test, and that test could be social approval. I would expect a significant difference between men and women social approval. I would expect men to be higher on social approval than women, because you see these averages are there. Also, the average, that's about 60% of people there. So the lowest average man is higher than the highest average woman when you take the center of the box. So I can really imagine those are going to be very different. Whereas when you look at the PV13, this nice red one there, the averages are about the same between men and women. Women have a tighter spread with some outliers at the top and bottom. Men have a broader spread, but generally positive. I would not expect a significant difference between those two. So this bar chart qualitatively investigates that. It doesn't prove anything, but it suggests something. So just because I want to find out for myself, I'm now going to run that test and investigate that for myself. So let's go to Analyze Non-Parametric, and it's going to be 2 independent samples. We're going to run a Mann-Whitney U-test because I know this data is non-parametric and we should be using non-parametrics. At least the data is non-normal, you should be using non-parametrics. So here we go. So I said these two were PV10 and PV13. Let's chuck those in. PV10, PV13. The grouping variable I'm putting in is gender. We've got Mann-Whitney U-test. Define groups 1 and 2. Let's click on that. Click OK. And here we go. So I said I expect PV10 to be significant and PV13 to be insignificant. Let's have a look. PV10 is significant and PV13 is non-significant. I was correct. So you can see that these kind of box plots give you a really interesting way to explore your data. If you are starting your analysis, doing a box plot is a good way to indicate where things can go and direct what tests you could do. Although, frankly, it's not necessary. You can just run tests anyway. But if you've got a small sample size and you can't run stats tests because of power analysis, then box plots are a really great way to indicate, I interpreted this, I say it suggests it, that's a qualitative insight, and then statistically, I know it's good. However, having said that, I also know that my sample size is a bit dubious, so maybe I should just stick with this bong. Anyway, that's a very, very quick look through at producing graphs, or charts, as we should be calling them. It really helps if you understand what kind of chart you're looking for in the first place, because there's a lot of options here and you can spend a long time going into it. But if you're going to have anything to do, box plots is my #1 favourite. Hope you found this useful and look forward to seeing you in the future.